Hi, this is Lady Lex UK and this is a Dreams gadget tutorial. Today we are looking at the calculator gadget in logic and processing. Here it is here. This is a nice easy gadget. It does exactly what it says it is. It is a calculator and it allows you to manipulate two separate numbers. So you can query those numbers and you can do mathematical things to them. So let's open it up and have a look. There is our calculator. So you can see it has two inputs, one for operand 1 and one for operand 2, otherwise known as A and B. I don't know why they decided to call it operand 1 when they had A and B in place, but hey. And then you've got outputs for those two numbers plus a result. So you would put the numbers that you wanted to calculate into these input sockets, and you would wire out the result to whatever you needed over here. So let's put in a number displayer. Let's just pop that down there, and we're going to make sure that our number displayer is going to show the decimal places. So I'll just put it all the way over to the right hand side so I get all the numbers that this calculator can give me. And let's put in some value sliders so I can add some numbers. Let's just up the maximum on that. There we go. So now we've got two value sliders, and I'm going to wire this one to A and this one to B. Right, so we're gonna up this value. We're gonna make that a 6, and we're gonna make this a 3. There we go. Right. So here are the results down here underneath, and these are the numbers I'm adding together. So this is add in the calculator. So we've got 6 at the top, 3 at the bottom, so our result is 9. Pretty self-explanatory. If I make it subtract, it will be 6 minus 3 equals 3. 6 times 3 equals 18. 6 divided by 3 equals 2. Now these are slightly different. These will give you a 1 or a 0 result. So this is asking, is this first number greater than the second number? And it's giving me a 1 as a result. If I was to move this value slider so that it is not greater than, so much bigger, you'll see the result changes to a 0. So anything lower, it's a 1, and then it's a 0. This is equal to. So if this first number is the same as the second number, it's going to produce a 1. Otherwise, it's going to produce a 0. So let's move it up to 6. There we go. You get a 1. Anything else, and it's a 0. And the same with less than. So is the first number less than the second number? At the moment, is the first number less than the second number? Yes, it is. If I go less than that, it's a 0. Right, this next one, remainder after division. This is a little bit more complicated. This is what was known in Project Spark as modulo. So those of you familiar with that all know what this does. This calculates the modulus of a number, and that is the remainder after you divided it from the first number by the second number. Let's divide equal number so you can see. Let's divide it by 2. Right, 6 divided by 2. That is a full number that will divide completely. 2 goes into 6 3 times without any remainder, so we get a 0 result. But if I just change the number slightly, now how many 2.1s in the 6? The remainder is 1.8. So if you if you were to divide 6 by 2.1, actually this is a very difficult number to actually, what shall I do? 4. Let's do 4. That's a nice, easy one to explain. Right, 4. So 4s go into 6 once with 2 remainder. So 6 take away 4 leaves you with 2 because it goes into 4. It goes in there once. So if I make it 5, that also goes into that once with 1 remainder. So 5 plus 1 equals 6. So if I go into the number 6, 6 goes into 6 completely, and so we get a result of 0. So what this does is calculates whatever's left over once you've taken away all the full numbers. So why is that useful and how could you use it? Well, in Project Spark, I used it for this. What I did was I set my waves to input to calculate a number. For every time it was a wave, it counted up. And for every 5th wave, say, so we'll change this to a 5. So for every 5th wave, I would put in a bigger monster, a boss monster on every 5th wave. So imagine this is, let's put that down to 0. If this is our wave count, and this is looking to see if it's a 5th wave, and if it is, the result is going to be a 0. So what we'll do is we'll put another calculator in, and we'll say, is this result equal to a 0? And then that result will either be a 1 or a 0, and that will power on your microchip or whatever it is that is running your code. So just to show you an example, I'm going to put a light in. So imagine this is our microchip that's going to launch our boss. Right, so we've got round 1. The light isn't on. It's not equally divided by 5. We go to round 2. Again, not. Round 3. Nope. Round 4. Nope. And then we get to round 5. And there we go. Our light's gone on. So in this instance, it will spawn our lovely boss. So this is what this is quite useful for. I've used in the past. And obviously, there are other ways you would need to use what the remainder is. You just want to know if one number will equally divide by another number with no remainder. You get a 0 result. And if you want to know what the remainder is, it gives you that number too. So that's quite a handy little function on the calculator. So let's get rid of that. We don't need that anymore. Let's put our number displayer back in. Again, don't forget, we want to see the whole number. Let's move that down out of the way. Right, okay, so that's that. Right, this one, minimum. This is looking to show the minimum number of these two numbers. So the minimum number at the moment is a 5. We've got 5 and 18.6. Let's move that down. So now 1.9. So if I move this one down to 0.7, it's showing me 0.7. So it's going to pick out the smaller of the two numbers that you present it. And this is the opposite. This is looking for the bigger of the two numbers and presenting that. This one is power of. Most of the time what you're going to want to do is the power of 2, which is square root, not square root, the square of a number. So let's do 5, a number that we can all recognise. So 5 times 5 is 25. So there we go. So the 5 to the power of 2 is 25. So this will times that number by however many you've got in this value slider down here. So if I set that to the power of 1, it'll be 5 on its own. If I put it at 0.5, it would be the square root, I believe, of 5, which is 2.236 recurring, I think. So there we are. So that's how to get the square root or the square of a number. Or you could do it 5 times 5 times 5, 6 times 6 times 6, 6 times 6 times 6 times 6 times 6 times 6, whatever you want to do, whatever number you've got in this second choice is the to the power of. That's what that does. Right, this one rounds down. This does not take into account this number at all. It only looks at the first number. So this is going to round down. So 6.7 will present as a 6. 4.8 will represent a 4. So there it's rounding down to the next whole number. This one will round up or down to the next number. So 4.8 is rounding up to 5. 7.1 is rounding down to 7. 7.5 or 8.5. 8.5 rounds up. So 5 and above will round up, and 4 and below will round down. That's what that one does. This one just rounds the number up. So 8.4 will go to 9. And 9.1 will go to 10. And this one is the absolute value. This is going to show you the absolute value of this number. So if it's a negative number, let me just change the value slider so we can get negative numbers. There we go. So if it's a negative number, it's just going to take that negative away. So it's 2.6. Negative 2.6 represents as 2.6. So if you've got something that's going to produce a negative number, but you want to see either side of that 0 as the same, then this is the way to do it. So it turns a negative number into its positive equivalent. There we go. Just removes that negative. So if you go up to the other side, 18.7 is 18.7. Minus 4.7 is 4.7. It just takes the negative away. And that's pretty much it. This is what the calculator does. And you can use this to query numbers. And like I say, you can pass that to other gadgets through this wire. So we've got it displayed to this number displayer. Don't forget, some gadgets will only display 2 digits or 1 digit. So you might not get the whole number displayed at the other end, but it is actually sending the whole correct number to however many decimal places it is to that gadget, even if it's not displaying the exact hit. So be careful with things like number displayers. If you don't want it rounding your number, as you can see there, we're getting a 5, even though we've got negative 4.7. We're rounding up. That should give us 4.7. We're getting a 5 because we've not shown the decimal point. So watch for that sort of thing. Be careful. Right, there we go. There's the calculator. Nice simple gadget for you. And there are lots of ways that you can use this. So thanks for watching, and I'll catch you in your dreams.